Hello everyone and welcome to Looking for Pythagoras 3.4. Our learning target today is we want to be able to find out if a triangle is a right triangle given the side lengths. After you've worked through the problem today, then our ACES questions will be 14 through 16 and number 24. Now remember, with the Pythagorean theorem, it is a right triangle. Okay, right triangle of a squared plus b squared equals c squared, or the hypotenuse side. One of the ways we've come up and used this Pythagorean theorem is figuring out lengths that can form a right triangle, and why this might be important is right here that in ancient Egypt the Nile River would overflow every year, flooded the surrounding lands, and often removed markers that were property boundaries or told people whose property was whose. As a result, the Egyptians had to remeasure their land every year. And to make sure that they had the angles done correctly, they would use a rope that had 12 equal intervals, and by tying knots in that. And that's how they would use, or what they would use, to be able to determine the property boundaries again. And one of the reasons for that is because they could have a length of 3 and a length of 4 and a length of 5. And if you added those up, that comes up to 12. Well, 3, 4, 5, if we turn that into a triangle, it makes a perfect right triangle with a side length of 3, a side length of 4, and a side length of 5. And 3 squared plus 4 squared equals 5 squared, or 3 squared is 9, plus 4 squared is 16, 9 plus 16 equals 25. We kind of found that out in investigation 3.1, filling out our table. So all we want to be looking at today is exploring a couple of questions about the opposite or converse of the Pythagorean theorem, and that means, is any triangle whose side lengths A, B, and C satisfy the relationship of a squared plus b squared equals c squared a right triangle? Meaning any measurements that fill a squared plus b squared equals c squared, does that make it a right triangle? And I'll let you pause the video here and think about that for a second. But yes, that makes it true that all side lengths that make a squared plus b squared equals c squared true are right triangles. And then it also says, suppose the side lengths of a triangle do not satisfy the relationship of a squared plus b squared equals c squared. Does that mean the triangle is not a right triangle? Again, you can pause this and think about it. But it does mean it's not a right triangle. All right triangles fit the relationship of a squared plus b squared equals c squared. And every triangle that does make a squared plus b squared equals c squared true, that is a right triangle. Okay, we're going to get some practice with this. These are side lengths that I'd want you to plug into a squared plus b squared equals c squared to see if it is a right triangle or not. If it makes it true, then it is a right triangle. If not, then it is not a right triangle. So we're going to be starting here with a squared plus b squared equals c squared. And my writing isn't getting any better with all the practice that I've had with this. But anyway, so in this first one we have 3 squared, okay, plus 4 squared equals 5 squared. Okay, so that's this one right here. Okay, so 3 squared is 9. So we talked about 4 squared is 16. And 5 squared is 25. 9 plus 16 is 25. 25 equals 25. So yes, this is a right triangle. So if it's true, if you wind up with both sides being equal, then it's true. Remember, the longest side is always the C side. So check those out, see which ones are right triangles, which ones aren't, and then work on ACES 14 through 16 and 24. Hope this was helpful. Good luck, and we'll see you in class.